All right. I believe we are live for the Google Hangout for the Unit 10 test, which is Solutions, Acids, and Bases. This unit is sort of chock full of essential skills. So if you look at your Q&A app, I have posted a number of questions to go through. And I'm hoping that you guys will join and put your own questions in there. But I thought I would go through and start with some of these, and should cover a lot of the material for the test and review your notes and worksheets that you've already done. Also, I'd like to cover a little bit of lab. And I know that review questions are always a sore subject. And so I think the things that are the most important that you should pay attention to, the most recent units, I think are the things that your memory needs to be jogged on. So we'll cover a little bit of that. I'm anticipating this would take about 45 minutes to an hour. It could be up to an hour if you have a lot of questions. If not a single person asks a single question, we could be done in a half an hour. So we'll see what happens. Last but not least, this is of course recorded and posted via YouTube, and I will put the YouTube link into our resources. So for those of you that weren't able to actually be there, you'll be able to watch it later. All right. So let's get started with the questions. And the first thing we'll talk about is, where is it? There's a question about solutes and solvents. And that question, that's like your first couple essential skills. And we'll probably do the same as we have in past units, where we combine essential skills into like one unit or one essential skill. So the essential skill that talks about solutes and solvents combined with the essential skill that talks about the factors that affect the rate of dissolution or how quickly something will dissolve, we'll probably combine into one essential skill and do the same thing for some other essential skills. Okay, I'm gonna share the Bamboo tablet. All right. And I'll try to keep my eye out for questions that you guys post on the Q&A app. So here we go. Oh, I don't like the thickness of this pen. I can run it thinner. Okay. Let's talk about essential skills. And first we'll talk about a solute versus a solvent. Okay. And so a good example of this would be if we have a cup, beaker, or whatever, and it has water in it. And inside of that, we have some sugar cubes. And let's make those be a fun color, purple. Okay. And I am no artiste. Okay. So here's a sugar cube. Okay, and maybe there's a couple sugar cubes because that's the way we roll. Okay, so sugar cube and water. So the question is, which one is the solute and which one is the solvent? And I like to approach this always from the solvent side of it. Solvent does dissolving. And just like the song, it does the dissolve. I can't even sing it. Does the dissolving. Anyways, I don't really care about the song. I mean, the song's okay. The way I look at this, solvent with the V right here. Let's circle these in orange. Solvent has a V in it. Dissolving has a V in it. That's the solvent does the dissolving. It is the medium that does the dissolving. And the other thing that I like to ask is always like, what is the universal solvent? And the universal solvent, oops, is water. So pretty much everything, for the purposes of this unit, for the purposes of what we're doing right now, everything's dissolved in water. And I think that makes it a little bit easier. So because it's a universal solvent, there you go. Solvent is always doing the dissolving. The solute, and we'll just right here, solute is being dissolved. Okay, am I spelling this right? Being dissolved. Okay, and that's where we get into the sugar. Okay, so whatever is being dissolved, it could be sugar, it could be salt, it could be Kool-Aid, it could be anything that you're gonna put in there. Tea, coffee kind of dissolves, I don't know, hot chocolate, whatever you can think of that gets dissolved into water or a water-based solution, solvent, that's the thing that's being dissolved. So then the next question is, well, how can we speed up? What affects the rate? I want things to dissolve faster. I gotta tell you, I want it to go fast. I don't wanna be sitting around waiting a long time. So factors, affecting rate, okay? Factors affecting rate. Well, if you want to dissolve something, you tell me, what would you do? Right? The first thing, you would probably agitate it. You would probably stir it up. Okay? And that's called agitation. Okay, that makes sense. You're gonna stir it up, you want it to dissolve faster. The second thing you would probably do is you would probably think, well, I'm gonna heat this up. Right, so we've got temperature. So if we increase temperature, that's also going to speed up the rate which it's dissolved. And then finally, we're going to break it up. And that would fall under the category of this surface area. Interestingly enough, there's some overlap between dissolution and the rate of a reaction. So that makes it a little bit easier to remember, but don't get them confused because there's just three. There's just three. And this is dissolution, which is the same thing as how fast you want it to dissolve. So if you break it up, so stir it up, heat it up, break it up, those are the three things that will speed up the rate of the dissolution, speed up the rate of dissolving. So that's pretty nice. Those are your first couple essential skills. All right, so let's put down here. So 1 to 2 or something along those lines. All right, so the solute solvent, and I think that answers that question. So let's go into another question. The next thing that I would expect there to be is talking about probably molarity. And molarity really ties into what we just talked about with solutions. I'm not going to number them anymore because you know what? I'm going to forget the numbers. It's going to totally mess this up. So we'll just call this the molarity essential skill. Fortunately, it's pretty easy. And molarity equals moles over liter. But you have to realize that we will probably ask you to rearrange this equation. We might say how many moles are in this equation. So where mole is equal to molarity times liters. Or we might say, what is the volume of this? Where liters equals moles over molarity. So there are three separate equations. And really, you're just manipulating the equation from the original equation to get them. But you never know. They can be asked many different ways. The reason I say you never know is while the essential skill may be very straightforward, could be something along the lines of what is the molarity of, let's go with 0.65 moles in, we'll probably say something like 750 milliliters. So this might look like, so 0.65 moles in 750 milliliters. So the essential skill is very straightforward. You would say, oh, well, molarity is equal to moles over liter, which is equal to 0.65 moles over, and you would remember that you have to divide this by 1,000, 0.75 liters. And so you get out your handy dandy calculator like I'm doing right now. 0.65 divided by 0.75, and using sig figs, because of course that's important, 0.87 molarity. So there's your answer. That's the essential skill. Very straightforward. I believe that everyone in our classes, plural, can get this correct. This is, though, where I want you to realize that I might as well talk about how we're going to deviate from that and make this a little bit more difficult. The more difficult questions are what's going to get you a higher grade. And I assume that if you're watching this, you probably want a higher grade. So the variations on this could be given a 0.450 molarity salt solution, which we're going to say is NaCl. How many moles in 0.37 liters? Okay. And in this situation, you would have to remember that, oh, it's back up here, moles equals molarity over liters. So moles equals, not molarity over molarity times liters. That's that manipulation equation. So mole is equal to 0.450 times 0.37. I should have used units, molarity liters. And so 0.45 times 0.37. Using sig figs, we only have 2 sig figs, so 0.17. I'm sorry, 0.17 moles. Okay, I think I did that right. So you can see that there are some different ways that could be asked. Now, the essential skill question will probably not look like this second one right here, or probably look like the top one. But I assume you want to know the other thing. So the other part of this question is, well, and then what's the difference between that and the dilution equation? And this is what kind of trips people up. I like to refer this very similar to the gas laws, okay? The similarity is that you have the ideal gas law, which is a single snapshot. So if we have a snapshot equals 1 moment in time. All right, that means that we're going to be using the molarity equals moles over liter equation. It's at that very moment. Here's the moles, here's the liter, what's the molarity? That's the snapshot. If there is a change in the solution, very similar to where in the gases, we had a change in the pressure or the volume or the temperature. Here you have a change in the molarity or the volume. If you have a change in the solution, that means you're going to use the M1V1 equals M2V2. And this is where you would have the dilution. And it might say the words dilution, or it might say add water. Okay? When it says those things, that's how you know you're dealing with a dilution equation. Let me come up with an example. I think that would be helpful for you guys. Okay. All right, so let's say that we have, what's a good one? I am going to, probably would have helped if I'd said this. So you're looking for, honestly, just as a reminder, you're looking for the words dilution or add water, final volume. These are all things that are telling you that, that are telling you that you're getting to the actual dilution, add water, final volume. Those are the things that are telling you that you're going to use this equation right here. So it might say something along the lines of Oh, I know what I'll say. Sorry. I'm sorry I didn't think of this ahead of time. What is the final volume of a solution with a 0.85 molarity concentration if the initial, oh, how about this? If water is added to a 15 milliliter added to, we'll just say added to 15 milliliters of 2.5 molar solution. I was trying not to be tricky. I'm always afraid that I'm going to end up with one of those questions that it asks you guys to calculate the amount of water that is added. I don't know if we have one of those in the test, to be honest with you. If there is, it's one question. So if you're looking at just trying to get a decent grade, maybe don't worry about that for right now. Focus on the things that you're good at. If you are looking at getting 100%, then you need to go back and study that question. But for this right now, M1, V1, M2, V2, the way we said that. And M1 and V1 are always the higher concentration, lower volume. Higher concentration, 2.5 molar, lower volume, 15 milliliters, okay? Then, because you're diluting it, you're going to a lower concentration and a higher volume. So the lower concentration, what we're looking for, or no, I'm sorry, we have that. That's not the one. We're looking for the volume. My apologies. Okay. The concentration 0.85 molar, and you're looking for the volume. Okay, we have our equation, M1V1 equals M2V2, and we're looking for V2, so that's equal to M1V1 over M2. So now we need to plug in our numbers. V2 is equal to, and the way that I'm doing this is the way that I would hope you would do it and be ready. I don't want you to confuse yourself on this. So following all the steps is highly recommended, especially on the free response. If you don't follow the steps, you don't get any credit. So V2 is equal to M1, so we have 2.5 molar times 15 milliliters all over 0.85 molar. So we plug that into our calculator. 2.5 times 15 divided by 0.85. And for a final volume, using sig figs, 2 sig figs, I get 44 milliliters. So hopefully that's pretty straightforward on dilution. At this point, I'm sure some of you have questions like, why do we have milliliters? What if we put it in liters? And remember that I told you guys, if you understand when the milliliters will cancel out, then leave it in milliliters. If this is confusing at all, you should just convert it to liters and then not worry about it, okay? In which case, this would be 0.015 liters, and so your answer would have actually been 0.044 liters, okay? So in the question, it would have probably specified if it wanted it milliliters or liters, or maybe it would have only given you one choice, given you all milliliters or all liters. Hopefully you guys can convert between milliliters and liters. So that's a piece that you need to remember. And to go from milliliters to liters, you need to divide by 1,000. So that's the next, let's say, part of that essential skill, dealing with molarity. And we've done that one now. So another question, before I do another essential skill, I see Diana has a question, so let's select that. Diana asks, for the study guide, since there are no answers, could you please post them so we can check our work? I think that would be fantastic. Unfortunately, I don't have time to do that, so I won't be posting that, but you are welcome to come and ask me some specific questions if you're unsure about any of the questions on the study guide. My apologies, just don't have time to do that. I don't usually do it for we don't often do it for the chemistry class, the Gen Chem. We don't usually post answers for the study guide. Okay. So there is actually, it looks like reaction rate had the most likes as far as a question goes. So why don't we do that one next? I thought we can go to acid bases, but I'd rather do the things that you guys want to see first. So it's the essential skill having to do with reaction rates, and it ties into several things here. So we'll just call this the reaction rates essential skill. And the first thing is the definition. So just real basic, the definition for reaction rate is the change in concentration of the reactants or products per unit time. Okay, so the change in concentration of reactants or products per unit time. Just the simple definition. Okay, so that's part of the essential skill. Another part of the essential skill would be saying, well, what two things happen? And if you see something like this, one, oops. All right, so the brackets mean concentration. So the concentration of the reactants goes down, and that would mean that the concentration of the products goes up. Now I'm using simple terms. Better terms would be decreasing or decreases and increases. I'm hoping you guys know what I mean. Okay, excellent. Then the next piece would be that I said, what is collision theory? And this is actually really huge, and I feel like I didn't really cover it. And it's honestly, it's not so much a part of the essential skill. So you know what, now that I think about it, why don't I come back to collision theory? Hold on. Okay, how about this? Collision theory is mentioned not as a part of the essential skill, but if you understand collision theory, you understand the essential skill so much better. So let's just talk about collision theory right now. I'm gonna put it in red because it's so important. So collision theory. And really, it goes back to the video of the how to get a date, how to speed up a reaction and how to get a date. You want molecules to collide. So what would be, you're looking for the best way to get molecules to collide. So you want them to collide. Number one, they have to collide hard enough. So, oops, I think I put a T at the end of enough. Not very smart. So in order to get them to collide hard enough, they need to be moving fast enough. For them to be moving fast enough, you're probably going to be looking at temperature. So temperature can cause molecules to run into each other pretty hard, running through the halls fast. That was the analogy. So if we increase temperature, then the molecules collide hard enough. So then we're going to have more reactions. Increase in temperature, increase collision. If we decrease temperature, we decrease collisions, and that decreases the reaction rate. So all of these are kind of a vice versa. All right. So one thing is increase in temperature. Another thing is if you want them to collide, they're floating around in water, the universal solvent, they're floating around. And if they're far apart, you're thinking, hey, they need to be closer together, because if they're closer together, they're more likely to collide. In order to do that, we're going to decrease the volume. So if we decrease the volume, now there's less space and they're more likely to collide. Now, if this were a gas, we would say just for gases, we would do this by increasing pressure. Because as you remember, pressure and volume are inversely related. PV inverse. Their relationship is inverse. How funny. Actually, since we're talking about getting a date, that analogy, the relationship between pressure and volume is inverse. Isn't that funny? I'm probably the only one that thinks that's funny. So if we decrease volume, then they're more likely to run into each other. If we increase pressure, they're more likely to run into each other. So that's another way of increasing the likelihood of molecules colliding. The next thing we'll put up here is there's just a few of them floating around in there. And so you're frustrated. How can I get more collisions with just a few of them? Well, what if we didn't have a few? What if we added more? Oh, then we would have more collisions. So more molecules. And we would do this by increasing, this is very important, increasing the concentration of the reactants. Okay, you can't just say increasing concentration. You have to say increasing the concentration of the reactants. So the way that I look at this is that, let's say that we're in the gymnasium and you want and you've got balls in there. You've got like the balls that we play dodgeball with or whatever. They're bouncing around in the gym, and you've got just a couple of them. Well, they're unlikely to run into each other. If you keep throwing them in there, but they're unlikely to run into each other. So you dump a whole bunch more balls in there. Okay, so now they're more likely to run into each other. However, if you put a whole bunch of people in there, the balls are more likely to run into the people than each other. And that's increasing the concentration of the products. So I'm going to change the color right here. So we decrease the rate if we increase concentration of products. So they just get in the way. Products, if you increase the concentration of products, they just get in the way. My analogy, of course, is the piles of bikes and tires, and the piles of tires and frames, and you're making bikes. And as you make more bikes, that's great, but now you have to climb over the bikes to get to the tires and frames. Climbing over the bikes takes time. You're slowing down the reaction rate. You're slowing down the process. So you need to get rid of those bikes. Somebody needs to come and clear out the bikes, and that way you then can speed up and make more bikes. So this is the piece, and I've talked about it before, comes up over and over again, that a lot of people miss out on. H2 plus O2 yields H2O. 2. So if we increase H2O, we decrease the rate of the reaction. Okay? If we decrease H2O, then we increase the rate. And I think the easy one for you guys will be, hey, if we increase the O2, that will increase the rate. And then the next question is, what if we decrease the H2 as a reactant? Then you should know that you are decreasing the rate. Hopefully that helps you. Okay, so we have done, just to go back for a second, because I think this gets forget, we have talked about the temperature. If we increase temperature, we increase the rate of the reaction. If we decrease the volume, we increase the rate of reaction. Or if we're talking about gases, we increase the pressure, we increase the rate of reaction. If we increase the concentration of the reactants, we speed up the rate of reaction. If we decrease the concentration of the products, we will also speed up the reaction. All right, the last couple things that I believe are pretty easy but need to be said. Number 4, add a catalyst. That will speed up the rate of the reaction. And the analogy was matchmaker. Remind me of Fiddler on the Roof. Matchmaker, matchmaker, make me a match. Da da da. You don't remember that? It's a good song. So you can add a catalyst, and last but not least, increase surface area. And this is, if you remember, breaking up the clumps. If you break up the clumps, you no longer have one large piece, but now there's smaller pieces that you can now get to the inside of that clump. Just as in the analogy with the person that's in the inside of the group, now they can be caught and they can get a date, I guess you could say. So collision theory ties right into the rate of the reaction. So we're not going to ask you what is collision theory or how to relate it, but you know the term collision theory now, and you understand that to increase the chances of collisions, you need to, and when we're talking about collisions, let's say we're dissolving solute solvent, because collision theory applies to dissolution as well. The contact is between the solute and the solvent. How easy is it to dissolve something? And again, increased temperature, then the molecules of the solute are attacking the solvent are attacking the solute and break it up. If we break up, we agitate, we make there'd be more collisions between the solvent and the solute. If we break it up, increase the surface area, that's another way that you can allow the solvent access to the solute to dissolve it, to break it up into tiny little pieces, make it go bye-bye. All right. So I believe that's actually that essential skill. And hopefully that helps you all be able to identify. You know what I should do though? How about if we do a little sample? And let's make this one, because I love these different colors. Let's make it orange. So we have our equation, 2H2 plus O2, and we're making these all gases, by the way, yields 2H2O, and we're making that a gas as well. So the questions, what if we decrease temperature? 2, what if we add a catalyst? Number 3, what if we increase H2? So increase the concentration of H2. 4, what if we increase the concentration of H2O? Number 5, what if we decrease pressure? So this could be similar to what you might see on the test. And you would have to write increase or decrease next to all of these. So if we decrease temperature, we decrease the rate of the reaction. If we add a catalyst, we increase the rate of reaction. If we increase the H2, it's a reactant. It's going to increase the rate of the reaction. If we increase the H2O, that is going to decrease, because now it's more in the way. And if we decrease the pressure, it increases the volume. These molecules spread out, and it's more difficult for them to collide with each other. This will decrease our rate of reaction. So hopefully that helps you with that. So that takes care of that essential skill. Last set of essential skills let's talk about those acids, bases. Interestingly enough, I saw a song on YouTube. It's all about the base, not the acid. So somebody has already done that song. It's pretty good. All right. So we're going to talk about acids and bases and their differences and similarities. You know what? Let's just do it like this. Let's spread it out on the paper right now. Now, I'm a big fan of Venn diagrams, but I don't feel like I'm going to be able to, there's so many words, it'll be difficult for me to fit it into the overlapping area. So the first thing I would say is you have to know the properties, right? Acids are sour. Oops. They're sour like lemons and lemonade. They're corrosive. And because they are corrosive, they eat away at like metals. So acids plus metals equals, or yields is what I should say, H2 gas. Okay. This is a single replacement reaction, by the way. Be a good thing to be able to recognize. Okay. You know what else? I don't know why I didn't think about this before. I'm gonna make this all in red. And I can do that because I'm cool. Sour. What else did I say? Oh, corrosive. Acids plus metals yield H2 gas. Okay, and this is a single replacement reaction. So an example of that could be magnesium plus hydrochloric acid. Oops, hydrochloric acid yields magnesium chloride plus H2 gas. Okay, litmus turns red. So see, I made the whole thing in red. Isn't that clever? Pretty straightforward. I can't think of anything else at the moment. Let's just go with that. And we'll make the bases blue. Bases are slippery. They are caustic. They, litmus turns blue, which is pretty straightforward. Trying to think of, oh, they are bitter. Why didn't I remember that? Bases are bitter and blue. Booyah. So slippery, caustic, turns litmus paper blue, bitter. Okay. So now the overlap, we're gonna make purple. Isn't that clever? Acids plus bases yields a salt plus water. And this is a neutralization reaction. Okay, and it is also a double replacement reaction. Oops. And this is probably one of the most key things, the thing that they have in common. If you understand this neutralization reaction, an example could be HCl plus NaOH yields NaCl plus H2O. So we combined, we combined the H and the OH, and we combined the Na and the Cl. So they just switched partners. All right. The pH is less than 7. It's basically, we'll say 0 to 6. And for the bases, didn't mean to write that in. Oops. The pH would be greater than 7. It would be 8 to 14. So this is pretty key. That's a major part of this essential skill. Obviously, there'll be questions about that. The next piece would be talking about we introduced the pHs. But you know what we should talk about? Let's talk about strengths. And so this was one of the questions. I can't remember if it was Pear Deck or Kahoot. Strong is saying that it dissociates completely. And another way of dissociating, another way of saying that would be ionizes completely. So dissociates or ionizes completely. Weak, obviously on the reverse, does not dissociate completely. So examples of this would be to say, I think that, I know HCl is a strong acid. So when it dissociates or ionizes into H plus Cl minus, when it's finished, we're gonna have 0% is gonna be HCl, the molecule HCl, and 100% is gonna be H plus, and 100% is gonna be HCl. It will dissociate in those two. However, a weak acid, HC2H3O2. This right here is acetic acid, it's vinegar. So let's say this is going to dissociate into H plus, and I'm going to make this an equilibrium, H plus C2H3O2 minus. When this finishes, it's going to have something there of 99% is going to still be this right here. 1% is going to be H plus, and 1% is going to be C2H3O2. This is clearly the weak, right? And this is clearly the strong. Now, it has nothing to do with the actual concentration or the pH. It has everything to do with how many molecules of H plus are you going to produce from the original molecule of the acid, or the original molecule of the base for that matter. And if you produce a whole bunch of H plus from that original molecule, then that's strong. It's at or near 100%. The weak ones don't produce very much at all. It is very low production of H plus from the original molecule. There's a lot of the H2C2H3O2, the original molecule, there's a lot of that still left because it hasn't dissociated. So that's what it means when it talks about the strength of an acid or the strength of the base. And then, the last piece of this that is a real struggle for most students is talking about the Arrhenius definitions versus Bronsted-Lowry. Arrhenius versus Bronsted-Lowry. I don't write this very well. Bronsted-Lowry. Okay. And Arrhenius only has one reactant, whereas Bronsted-Lowry has two reactants. There has to be a donor and acceptor. You have to have a donor and acceptor. Whereas Arrhenius just increases concentration. So for example, because I like it so much, HCl goes to H plus Cl minus. This is the acid because it starts with the H and increases the H plus concentration. NaOH, Na plus OH minus. Because it ends in OH, it increases the OH minus concentration. This is the base. So you only have to look at the reactant side. Determine from the reactants. Whereas on this other side, It's a little unusual because you have to have two things. You can't just react HCl and NaOH. It's not going to work. What will work is HCl plus H2O. And in this case, you end up with H3O plus Cl minus. Now, what happened here is that the H ended up going to the H2O, which is why you have this H3O plus. So that means that the HCl is the acid because it is a proton donor. H plus donor and H plus acceptor. It's about the H's. It's all about the H's, okay? And the H2O, because it accepted, because it accepted that H plus, becomes H3O plus. That means that it is a Bronsted-Lowry base. If I did this, NH3 plus H2O, and in this case, we end up with NH4 plus OH minus. Now what happened is that an H ended up going to the NH3, and the NH3 became NH4 plus, which means that the H2O is the acid and the NH3 is the base. And you look at that and you recognize that water can be an acid and base. That's called being amphoteric. If it behaves like an acid and base, amphoteric. Or you might say it's amphiprotic because it can donate and receive an H. Anyways, that's what happens. The H2O loses an H, so it is the acid. It donated the H. It's an acid. And H3 is a base because it accepted an H. Now, I also want you to pay attention to the fact that we only label reactants. I cannot emphasize that enough. If you forget, then you will get these questions wrong and you will be frustrated. Only label the reactants. We only labeled the reactants here. We only labeled the reactants here, 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 and here. It was only the reactants. If it's Bronsted-Lowry, there are two of them. If it's Arrhenius, there's only one. That's how you'll know which definition of an acid you will be needing. So hopefully that gets you caught up on the essential skill of definitions of acids and bases and understanding the pH. It, of course, segues quite easily and nicely into talking about pH and pOH. So I'll do that briefly before we go into the lab question. If you're given a concentration, that concentration could be 2.5 times 10 to the negative 6th molar HCl. And the question is, what is the pH? You have formulas, I believe, on the back of the periodic table. So hopefully you don't forget about that. I'll try to remind you at the day of the test. I don't know if I will, but I'll try to. pH equals negative log of the H plus concentration. Now, that's the same thing as saying pH is equal to negative log of the H3O plus, because H plus is the same thing as H3O plus. The reason being, these protons do not float around by themselves. They always attach to a water, making what's called hydronium. That is in your notes. Hopefully you'll remember that. So you're only going to plug in the molarity of your acid in for the H plus. Pretty straightforward. So pH is equal to negative log 2.5 times 10 to the negative 6th. And so I do that. negative log 2.5 exponent negative 6. And my pH ends up being 5.6. Pretty straightforward. That was the P, and it's unitless, so you don't have to remember to put units on that. Excuse me, drying out a little bit. I think that's pretty straightforward. And for those of you that remember the shortcut, if I had said 1 times 10 to the negative 5th, then the pH would be 5. If I had 1 times 10 to the negative 6th, the pH would be 6. And so 2.5 times 10 to the negative 6th, interestingly enough, is right in between the two of them, not exactly between, but it, and because it's log, it doesn't work exactly like we might expect, unless you know logs, and you get the 5.6, which is right in the middle. So you can kind of predict where it's going to be if you think about it, if you wanted to double check your work. Now, let's say that I had said, oh, it's 2.5 times 10 to the negative 6th molar NaOH. What is the pH? So in this situation, you would have done the same thing, except for that it would have had to have been POH, because it's a base. POH is equal to negative log of the OH minus concentration. So you would plug it in here. POH is equal to negative log of 2.5 times 10 to the negative 6th. And that would have given you a POH of 5.6. That would not have been your answer then. You would have had to deal with the equation pH plus POH is equal to 14. So to get the pH, you have to do 14 minus the POH. So 14 minus 5.6. 14 minus 5.6, I could probably do that in my head, but I chose not to. It's equal to 8.4. So that's how you go in between pH and POH. The last question I want to throw out at you, not the last question, but the last part of this before I go on to the lab, would be that quite a few people seem to struggle with this equation. H plus times OH minus equals 1 times 10 to the negative 14th. And so we would give this to you and say, oh, and the concentration of the HCl is equal to, just because I'm already on 2.5 times 10 to the negative 6th. So what's the concentration of the OH minus? And we could word that question however we wanted to, but you have to recognize that we're going to give you one of those two numbers. So this is algebra, you're just solving for the other one. So the OH minus is going to be equal to 1 times 10 to the negative 14th divided by the H plus, which means it is 1 times 10 to the negative 14th divided by 2.5 times 10 to the negative 6th. Now this is not a pH question at all. It's just asking you for concentration. So if I plug that into my calculator, and my OH minus concentration ends up being 4 times 10 to the negative 9th. Molarity. Sorry, I should have put the units on these. It would help a lot more for that. Okay. There might be one like that on the test, I don't know. But we just had 2 on the worksheet. So that means we are not done with that question. Last but not least, we're doing pretty good on time. I'm surprised actually that it's taken this long. I thought it would only be a half an hour. The lab. Oh, so much fun. Let's do the lab. Okay, so as you know, there's a better than average chance that it's going to be on the free response. If not, it'll just be multiple choice questions. Either way, it's fine. So I'm going to do a setup here. So we have a ring stand and a base And then there's a clamp. Now, the clamp was a bigger clamp than what I'm about to draw, but you get the general idea. Okay. And I'm drawing more along the lines of the picture that's in your notes. Okay. So I'm going to, I guess I'll do it on black. I have a hard time doing this. Mainly because I have no artistic skill. Haha. Okay. And here we have the Erlenmeyer flask. Something along those lines. And there's a fluid in there. And there's a fluid in here. Okay. So you have to know what this is. Oops. You gotta know what this is. And you need to know what this is. Okay, and what's gonna happen. So here, I'll give you a little sample question that will hopefully walk you through this. All right. And so my sample question is this. You are trying to determine molarity of, let's give 12.5 milliliters of NaOH. Titrate with 16.5 milliliters of 0.650 molar HCl. Did I do that right? Okay. So you've got to go through all the steps to get this. What are you going to put where and with what order? So the first thing, if you guys remember, what I always try to say is that your known, you should put in the burette, and the unknown, you're going to put in the Erlenmeyer flask. So your known in this case is, you know, 60.5 milliliters of 0.650 molar HCl. So 16.5 milliliters, 0.650 molar HCl. Your unknown in this case is the molarity of the 12.5 milliliters of NaOH. 12.5 milliliters NaOH. Okay, good. Now, if you also remember that in the Erlenmeyer flask, if you guys forgot your indicator, then you would not know when your reaction changed color. You wouldn't know when it ended. So you have to add the indicator. So plus indicator. Now, you probably remember from the lab, not necessarily, you may remember from the lab that the indicator when you're dealing with a base is methyl orange. You don't have to have that memorized for the test. If it had been acid, you would be doing phenolphthalein. But it's not important, as long as you recognize that you have to do an indicator. Okay, and now we're going to solve the problem. So the titration equation, MAVA equals MBVB. And your unknown is the acid, so you're looking for the molarity of the acid. You got to show all the steps. MA is equal to MBVB over VA. And the molarity of the base is equal to 0.650. Oh, wait. I did that backwards. Of course I did. Sorry. Perdonez-moi. Did I mess it up? Let's try that one more time. We're looking for the NaOH. MAVA equals MBVB. We're looking for the molarity of the base. Molarity of the base is equal to MAVA over VB. Okay. MA is equal to 0.650 molar HCl. VA is equal to 16.5 milliliters. And VB is equal to 12.5 milliliters NaOH. And this is HCl. So I plug those in. MB is equal to 0.650 molarity times 16.5 milliliters all over 12.5 milliliters. Very similar. This is very, very similar to the M1V1 equals M2V2. This is a neutralization reaction, though. A double replacement neutralization reaction. I'll talk about that in a second. And so the MB ends up being, I think you plug it in your calculator. I did calculate this one ahead of time. 0.858 molar NaOH. Yay. Okay. And just as a reminder, neutralization, and it's a double replacement. Okay. Now, once you have that, we may or may not ask you, I don't know, if 0.858 molar NaOH, what's the pH? So of course you do POH, because it's a base, is equal to negative log of, well, OH minus, which in this case, POH is equal to negative log of 0.858. So I actually didn't do that. Negative log of 0.858. And interestingly enough, POH is equal to 0.07. Yikes. Or you know what? I'm going to, with sig figs. Well, and sig figs are, I've told you before, I don't really care about sig figs with log because they have their own rules. So just do that. And so then 14 minus POH is equal to pH. So it's equal to 14 minus 0.0665. And so we're getting the pH is equal to 13.9. That's a pretty high pH, but it's a pretty strong NaOH, which is fine. All right. Before I leave acid bases and talk a little bit about the review questions, I also want to make mention, and I don't know if it's on the test. I expect it to be on the test, but it could be wrong. If it was H2SO4, and we're going to do the molarity, MAVA equals MBVB, you know that you have to double the concentration, right? Excuse me. Because this is the moles of H plus being equal to the moles of OH minus. And so if you solve for MA, MA is equal to MBVB over VA. If you solve for the MA, really that's the concentration of the H plus. And so if you want to get your H2SO4, you're going to have to say, oh, it's 2 moles of H plus to 1 mole of H2SO4. So that means you're going to have to divide that by 2. However, if let's say you're solving for MB, and that's the M2, it's MB is equal to MAVA over VB, you're going to have to take this one. This is where the H2SO4, the concentration of H2SO4, for every 1 mole of H2SO4, it's 2 moles of the H plus. So you're going to have to double it. You have to multiply by 2. So this is 2 times, and right here, it's divided by 2, depending on how you plug it into the equation. Again, that's something that if this is confusing to you, ignore it. Ignore it, because I want you to focus on the things that are most important. And those essential skills are the most important things. Get those down first. All right. All right, so now we're done with all the acid-base stuff. So what I'll just touch on real briefly, little bonus Easter egg, right? Or whatever it is. These are the things that I would tell you to review for the test. Okay, you need to be ready to do a PV equals nRT. Okay, you know that pressure is in atmospheres, volume is in liters, N is mole, R is, and this is on the back of the periodic table, liters atmosphere over mole Kelvin, and temperature is in Kelvin. So let me just circle these. Okay, so you need to make sure you know all of that and be able to manipulate that equation and solve. So if you are wondering about that, go back and maybe do the study guide or do the review, the Schoology review quiz. You should also be able to do the P1 V1 T2 is equal to P2 V2 T1. It seems to me that a lot of people are confused on the actual numbers. The way that I always remember it, P1 V1 T1 is equal to P2 V2 over T2. So it's over, the temperatures are on the bottom. And then you can do a cross multiplication. So write it this way first to remember, then move them up there. So then you know the P's and V's have to both be the same number and the T is the opposite number. So hopefully that will help you. So make sure that you do this. The temperature here is the only thing that needs to be in Kelvin. But be prepared to do those two gas laws equations. The next thing I would tell you is, and again, these are all just essential skills, thermo. So this was gases. In thermo, there's two equations, okay? So we have the Q equals M times CSP times delta T. Times delta T. And you know that the M is grams, the CSP is in joules per gram degrees Celsius. And the delta T could be degrees Celsius, or it could be Kelvin, because we know that a change in temperature, a 1 degree change in temperature is the same in Celsius as it is in Kelvin. Okay. And then the other one you need to pay attention to is Q equals M times delta H. And that's just mass, again, which is grams. And the delta H is in joules per gram. So the grams cancel out, leaving you with joules. Q is always in joules. Q is always in joules. So there's two questions you need to answer, though. When you're doing this, are we talking about delta H of fusion, or is it delta H of vaporization? Very important. And is heat being added, or is heat being taken away? Is it going to be positive, or is it going to be negative? Very important when determining your Q equals M delta H to know which one to use. So again, go back, take a look at that. The last thing that I want to mention is stoic. There's always questions about stoic. And really, for that one, it's the gram to gram bridge. So if you remember, you have grams of A over the molar mass in grams of A to 1 mole of A. And then you have this is the mole ratio, moles of A to moles of B, and this is the coefficient. Should have given myself more room. Coefficient. And then for 1 mole of B, we have the molar mass in grams of B. So I would suggest you write down this, like when you get it, maybe on the back of your free response sheet, you write this bridge, and then you can do anything within the bridge, right? If you're converting grams to moles, it's right here. If you're converting moles to grams, that's also right here. If you're converting with the mole ratio, that's right here. Moles to moles of different substances. So it's all right there. If you have that bridge to work with, everything gets easier after that. Okay, so those are all the main things that I want to talk to you guys about. We only had the one question. It was really just looking for answers on a worksheet, the study guide. But I'm hoping that all this made sense and that it's getting you on the right path to do well on the test. Please come in and see me if you have any questions. The test is Tuesday and Wednesday. There will possibly be a retake. We'll have to see. I think it's going to really depend upon, I mean, obviously it always is, but people's grades. Like if you're really going to be able to change your grade by doing a retake. And if we do the retake, I don't even know, it could be the last day of school. We'll have to see. I'll talk to Demery about that. So anyways, I hope you guys get some rest in the next couple nights, eat well, and be ready for the test on Tuesday and Wednesday. Thanks guys, and I'll see you later.